Welcome and thank you for joining Module 2 of our training series. In this module, we're diving into a topic that sits at the very heart of modern vocational education, active and inquiry-based learning.
Over the next 10 minutes, we'll explore how to move beyond traditional instruction to create dynamic learning environments where your students don't just receive information, but actively investigate, experiment, and build solutions for real-world sustainability challenges.
So, let's begin our journey into active and inquiry-based learning, where students stop being passive receivers and start becoming active investigators, creators, and problem solvers.
Let's start with an honest question. Think back to your own training or a recent professional development session. How much do you remember from a lecture you sat through 6 months ago? Probably not much, right? Now think about a time you learned something by actually doing it. Maybe you learned to use a new piece of equipment by hands-on practice, or you figured out how to solve a problem by working through it yourself. That learning probably stuck with you. This isn't just anecdotal. Educational research has known for decades that passive learning, where students sit and listen, is one of the least effective ways to transfer knowledge. Edgar Dale's research, summarized in his cone of experience, shows that people remember only about 10% of what they read and 20% of what they hear. But when they actually do something, retention jumps to 90%. Traditional teaching often positions students as empty vessels to be filled with facts. Active learning, by contrast, positions them as architects of their own understanding. As adaptive teachers preparing students for the unpredictable world of sustainable entrepreneurship, we need our students to be builders, thinkers, and problem solvers, not just note takers. Active learning is the engine that drives this transformation.
So, what exactly is active learning? Let's get a clear definition. Active learning, as defined by Bonwell and Eisen back in 1991, is any instructional method that engages students in the learning process. The key phrase here is, engages students, not just physically, but mentally. Students aren't just showing up. They're thinking, doing, and reflecting. Let's give some concrete contrasts to see the difference. Active learning is students solving problems, not just memorizing solutions. It's discussion and collaboration, students talking to each other about the content, not just to the teacher. It's hands-on activities where they manipulate materials, data, or ideas. And crucially, it includes reflection, thinking about what they learned and how they learned it. The teacher's role shifts from being the sage on the stage to the guide on the side. Active learning is not passive listening. It's not students working alone on worksheets with no interaction. It's not memorizing facts that will be forgotten after the test. And it's definitely not busy work, activities that keep students occupied but don't lead to deeper understanding. Let's check some specific examples to make active learning concrete. Instead of explaining the business model canvas, you'd give students a blank canvas and say, here's a concept for a smart jacket that charges your phone. Work in teams to figure out how this business would make money. For sustainability, instead of showing a documentary about textile waste, you challenge students, investigate where your own clothes come from. Track one t-shirt from raw material to your closet. Present your findings to the class. Here is the difference. In each case, students are doing something with the information, not just receiving it. That's active learning.
Now we come to one of the most powerful forms of active learning, inquiry-based learning, or IBL for short. First, let's make a clear definition. Inquiry-based learning is a form of active learning that starts by posing questions, problems, or scenarios, rather than simply presenting established facts. Instead of saying, here's how a circular economy works, you say, how could we make this product part of a circular economy? The emphasis is on the student's role in investigating and constructing meaning for themselves. IBL follows a natural cycle, a rhythm of learning that mirrors how humans have always learned, from children exploring their world to scientists making discoveries. Let's walk through the 5 phases. Phase 1. Ask. It all starts with a question. The key is that the question is engaging, open-ended, and worth investigating. Phase 2. Investigate. Now students go to work. They research, experiment, collect data, interview people, whatever their question requires. Phase 3. Create. Based on their investigation, students create something, a model, a prototype. This is where they synthesize their learning into a tangible form. Phase 4. Discuss. Students share what they've created. They present to peers, answer questions, and give and receive feedback. This phase is crucial because it exposes them to different perspectives and approaches. Phase 5. Reflect. Finally, students step back and think about the process itself. This metacognitive step, thinking about thinking, is what turns experience into deep learning. Here's a critical insight. The cycle doesn't end at reflection. Often, reflection generates new questions, and the cycle starts again at a deeper level. This is how learning spirals upward, building complexity over time.
One of the most common misconceptions about inquiry-based learning is that it's all or nothing. Either you're doing open-ended, student-led research, or you're not doing inquiry at all. That's simply not true. Inquiry exists on a continuum. As an adaptive teacher, you move students along this continuum based on their readiness, the content, and your learning goals. Let us explain the 3 levels. Level 1. Simple or structured inquiry. At this level, you provide both the question and the method. Students follow your procedures to discover the answer. The outcome, however, is still open. There might be multiple valid conclusions. This is like a cooking class where you give students the recipe and ingredients, and they follow the steps to create the dish. They're still learning actively, but with heavy scaffolding. Level 2. Guided inquiry. Here, you provide the question, but students choose their own method of investigation. You're saying, here's the problem, you figure out how to solve it. This is like saying, make a dish that uses seasonal, sustainable ingredients, and letting students choose the recipe and cooking method. Level 3. Open-ended inquiry. At the highest level, students develop their own questions and design their own methods. Your role becomes mentor and resource provider. This is like saying, explore something interesting about food and sustainability, and supporting students as they pursue their unique interests.
Now let's make this concrete with a detailed example titled as the circular smart jersey that you could actually use in your classroom. Imagine you're teaching a unit on sustainable business models. Instead of lecturing about circular economy principles and then giving a test, you launch this inquiry project. You begin with the ask phase. You pose the central question: how could we redesign a sports team's jersey to be smart and part of a circular economy, eliminating waste? Then students move to investigate. They need to explore 4 interconnected areas. First, smart functionality. Second, circular economy principles. Third, sustainable materials. Fourth, user needs. This investigation phase might take several class periods. Students work in teams, divide up research tasks, and gradually build their understanding. Teachers' role is to provide resources, articles, videos, connections to industry experts, and to ask questions that deepen their thinking. Next, the create phase. Each team synthesizes their research into 3 concrete outputs. Then, discuss. Teams present their pitches. But here's the key: the audience doesn't just sit there. They use a structured feedback protocol. Finally, reflect. Students write a short journal entry. What was hardest? How did their thinking evolve? What new questions emerged? This reflection is where the deepest learning happens. It's where students consolidate what they've learned and identify what they still want to explore. What's powerful about this project is that it integrates everything: technical knowledge about textiles, business modeling skills, sustainability principles, collaboration, communication, and creative thinking. Students aren't just learning about sustainable entrepreneurship, they're doing it.
It's time to focus on selecting and applying digital tools. These tools can dramatically enhance an inquiry. Imagine a student investigating the business viability of a sustainable material. Instead of just reading about it, they could use a simulation to adjust production costs, retail price, and recycling rates, and immediately see the impact on profitability and waste reduction. This makes abstract concepts tangible. Similarly, an educational game could place a team in charge of a virtual smart clothing startup, forcing them to make real-time decisions about sourcing, marketing, and sustainability, and learning from their failures in a risk-free environment. The right digital tool transforms an abstract inquiry into an immersive, hands-on experience.
One of the biggest challenges teachers face with inquiry-based learning: assessment. How do you grade fairly when every student or team is doing something different? How do you value the process, not just the final product? Assessing an inquiry project with a single, final test is like judging a marathon runner only on their final sprint. You miss all the training, the strategy, and the perseverance. For the circular smart jersey task, a good assessment strategy balances the process and the final product. We weigh the formative elements like their research journal, their participation in peer feedback, and the personal reflections more heavily. This sends a powerful message to students. We value your curiosity, your ability to navigate ambiguity, and your willingness to take creative risks just as much as the final outcome. This aligns perfectly with the entrepreneurial mindset we want to foster.
Let's be realistic. Shifting to inquiry is challenging. You might worry about time, about losing control, or about managing chaos. These are all valid concerns. But as we saw in Module 1, adaptive teaching isn't about doing everything alone. The rest of this course is designed to give you the tools to overcome these hurdles. When you learn to structure inquiry effectively, it saves time in the long run because students develop deeper, more transferable understanding. When you use digital tools like simulations, they do some of the heavy lifting of managing complexity. And when you connect inquiry to authentic, entrepreneurial challenges, student motivation increases, and many classroom management issues simply disappear. You're building a toolkit for success, one module at a time.
Congratulations! You've completed Module 2. You now have a foundational understanding of how to use active and inquiry-based learning to foster curiosity and entrepreneurial thinking.
You've seen how it connects to our core frameworks and the challenges it can help you address. Before moving on, please invest about 25 minutes in the excellent additional materials linked in the syllabus. They provide even more practical strategies and examples. Thank you for your attention.